Hey everyone, today we're going to jump in and we're going to learn how to write half reactions. So, as a little bit of a recap, we are going to write half reactions for redox reactions, also known as oxidation reduction reactions. Again, remember this occurs because there is a transfer of electrons. Just as a general reminder, oxidation means that I have lost electrons, or you're going to see an increase in your oxidation number. A reduction is when you are gaining electrons, and because you're gaining a negative charge, you're going to see a decrease in your oxidation numbers. Now, the part of the reaction involving oxidation or reduction alone can actually be written as something known as a half reaction. So, half reactions, you can take an entire reaction and write a half reaction. So, for example, if I said I had 3 sodium reacting with aluminum chloride, it's going to yield solid aluminum and sodium chloride. The number one thing that you're going to do is write the net ionic equation for this reaction, which we did last semester in chapter 4, where we split apart ions. The second thing you would do is assign oxidation numbers and then eliminate substances that are not being oxidized or reduced. Now, fun fact for you, I do these steps for you, so you do not have to do these. So I did these for your homework. The third step, which is the one that we're focused on, is actually writing half reactions. Whenever we write half reactions, we're going to write a reaction for who's being oxidized and one for who's being reduced. And so I'm going to walk through 2 examples, but there's a couple things in order to write half reactions. We need to first balance the number of atoms. And to help us do this, I'm going to do an example where we're going to be using water and hydrogen to help balance oxygen. And then we also have to make sure, since we are working with charges, that our charges are balanced as well. And we do this by using electrons, and we have to remember electrons have a negative charge. Lastly, based on which side of the equation electrons are placed, we can actually determine who is reduced and who is oxidized. Now, that may sound like a big mouthful, but we're going to walk through 2 examples, so please make sure that if you do have questions along the way, you guys ask. Here, I've already split apart into the net ionic equation and eliminated it. So in your homework, I will give you something that looks like this. First thing that we need to do is write half reactions. So notice that sodium and sodium are going to come together. So I have 3 sodium yields 3 sodium ions. So that's one of my half reactions so far. The other one, if we split it apart, aluminum and aluminum go together. So aluminum ion yields solid aluminum. From there, we have to make sure that my atoms are balanced. Notice here I have 3 sodium, and this one I have 3 sodium. Down here, I have 1 aluminum out front, and here I have 1 aluminum. So my atoms are balanced. I don't have to do anything different. Next, I have to make sure that I balance my charges using electrons. So notice over here, I have no charge on the left-hand side. However, on the right-hand side, I do have a charge. So over here, I have a 3 times a plus 1. So I actually have a plus 3 charge on the right and no charge on the left. And we have to make sure these equal. And we do this by using electrons. So remember, like I said, electrons have a negative charge, so it can only bring down numbers. We tend to put electrons on the side of the equation that is positively charged to bring that positive down. So notice here I have a positive 3, and I want to bring it down to a 0. So what we're going to actually do is add 3 electrons onto this right-hand side. So positive 3 minus 3 gets me to 0. So here is my first half reaction. If we're going to work on my second half reaction, here we're going to make sure we've already have the atoms balanced, but we have to make sure the charges balance as well. On the right-hand side, our charge is 0. We're fine. But over here on aluminum, I have a plus 3 charge. We're going to add electrons in order to make sure they match. Again, we're going to tend to add electrons on the biggest side, the most positive side. So over here, I have a 3 plus, and in order to get down to 0, I'm going to add 3 electrons. So notice I have a 3 plus a 3 minus gives me the 0 that I should have. So right here, this is my second half reaction. So over here, I just rewrote them to show that I have my half reaction for sodium and my half reaction for aluminum. And one thing I do really want to point out on this slide is depending on which side you put the electrons tells you if it's an oxidative reaction or a reduction. So over here, if you ever put electrons on the right-hand side, this is typically going to be oxidative reaction because you have lost electrons. Notice how the electrons are on the product side and they're away from sodium, saying that they have been taken away. Reduction, typically you're going to find these electrons written on the left-hand side to show that, hey, it's a reactant, I'm actually gaining it to become a single thing. These 3 questions I have down below explain the process of why we do this. Because of the law of conservation of mass and charge and everything, 1, how does this reaction illustrate that charge is conserved in a redox reaction? We can see that charge is actually conserved because if we look at the overall reaction, here we have a 3 plus charge on the left. Over here on the right, we have a +1, but there's 3 of them, so we have a 3 plus on the right. Notice that my charge is equal, so that's what I mean by charge is conserved. Next, explain how mass is conserved. Mass is conserved, and the reason for this is because we have the same number of atoms of each element. Notice I have 3 sodium on the left, 3 sodium on the right. 1 aluminum on the left, 1 aluminum on the right. And then last but not least, it says explain why electrons do not appear as a reactant or product whenever we combine redox reactions. And we're going to see this mostly in the lessons coming up, but here I have 3 on the left and here I have 3 on the right. We're going to see that they cancel for this example. I am not going to have you do that for today's homework. Here is another one that we can go through about writing half reactions, but this one is a little bit harder. So I'm going to split this up. We have manganese going to manganese, so that's why I rewrote it down here. And we have carbon and oxygen, again, going to carbon and oxygen down there. So I've split them up here. The first thing that we need to do is balance the number of atoms first. Here I have 1 manganese. I have 1 manganese over here. Here I have oxygen, but there's no oxygen on the right-hand side, and this causes an issue. The way we solve this issue is because oftentimes these occur in an aqueous solution, so we're going to use water and hydrogen ions to actually help us balance this. The way it works is I have 4 oxygen on the left. So to get 4 oxygen on the right, I'm going to add 4 H2Os. So notice I now have my 4 oxygen, but this leaves me in another predicament. I have 8 hydrogen now, but there's no hydrogen on the left. So what we do is we counterbalance it by putting 8 hydrogen ions on the left. Now your atoms should match up. 8 hydrogen, 1 manganese, 4 oxygen, 4 oxygen. From there, we have to make sure that we balance our charges using our electrons. So what we're going to see over here on the left-hand side is I have 8 plus 1 charges. So I have a plus 8, and then I have 1 negative 1 charge. So minus 1. This gives me a total of 7 on the left. Over here on the right, this compound's neutral, so we don't worry about this, but we have 1 plus 2 charge. So I have plus 2 over here. We need to make sure that these numbers match. So the way we do that, again, is we introduce the idea of electrons. We put electrons on the most positive side. So over here, we have 7, and in order to get down to 2, 7 minus what number will get me to 2, and that's 5. So we're going to add 5 electrons because that subtracts 5 to get me to 2. So right here, this would be my half reaction. If I look down at my next example and I am trying to get a half reaction, here we have carbon. We need to make sure it matches. I have 2 carbon on the left. In order to get 2 carbon on the right, I'm going to add a 2 in front. This gives me 4 oxygen on the left, 4 oxygen on the right. So my atom's balanced. So even though there was oxygen, I actually didn't have to use water in this instance, which is why I used this example. After we get that, we need to make sure we balance our charges. So here I have one molecule of a 2 negative, so that's -2 on this side. Here I have a neutral compound, so that is 0. We want to make sure that these match, so we have to add our electrons to whichever side's the most positive, which ends up being this side. So how do I go from 0 to -2? Well, you're going to add a 2 electrons to get me to my -2 to balance each side. So if I were to write a half reaction for this side, it would be the following. So here I have a lot of simple examples that we can walk through and go through to make sure that we're understanding what's going on. Here I have it where they don't have oxygen, and I have you telling me if it's being oxidized or reduced. If we look at potassium coming into potassium ion, I have 1 of each atom, so atoms are balanced. Here I have a +1 charge, here I have a 0 charge. So what I could do is I could add 1 electron to the right-hand side of this equation. When I add 1 electron, that makes this side 0 and this side 0. Because I added my electron to the right-hand side, this is telling me that I have lost electrons. So losing electrons, you are being oxidized. Over here, magnesium works the same way. I have 1 magnesium atom, 1 magnesium atom, but my charges aren't balanced. Here I have a 0 charge, and here I have a +2. So in order to get this +2 down to 0, you can add 2 electron charges because they have negative. And again, since I added electrons to the right-hand side, this is oxidized. Here we have sulfur. Sulfur is another example. Here I have 1 sulfur and 1 sulfur, but my charges do not balance. Here I have a 0 charge, and this is a -2. So again, the only way is to go down. So you can actually add 2 electrons. So I have a -2 over here and a -2 over here. And since I added my electrons to the left of the arrow, this is actually reduced. Gaining electrons, reduction. Over here, this is where we see an instance where I don't have the appropriate number of atoms. Here I have 2 atoms, and this one I only have 1. So you can actually add a 2 coefficient out front to balance your atoms. And then we have to make sure that we balance our charges. Here I have 2 to -1, so that's actually a -2 charge on the left. This one is a 0 charge on the right. So in order to go from your most positive down, we're going to add 2 electrons. So here we added electrons to the right-hand side. We're going to see that this is oxidized. And then I wanted to make sure I threw in some examples with adding water and hydrogen again. So here are some where you can work with oxygen within your half reaction. I am going to cross out this one because we did this one on a previous slide. So we have 3 that we're going to work through. Here we have 1 manganese. Here we have 1 manganese. Here we have 4 oxygen, we have 2 oxygen. So my oxygens don't balance. But whenever you change the coefficient on this one, it's obviously going to affect this one. And you're going to see that there's no other way to balance this than add water. Here I already have 2 oxygen and I want to get to 4. So I'm going to add that many waters. So I have 2, 4 oxygen, 4 oxygen. Beautiful. Then what we're going to do is we need to balance our hydrogen that we introduced. So here I have 4 hydrogen, so I'm going to introduce 4 H plus ions over here. Next, what we need to do is we need to make sure that my charges balance. In order for my charges to balance, notice I have 4 plus 1 charges. So I have plus 4, and then I have 1 negative 1 charge, which gives me a total of 3 on the left. Over here, both these compounds are neutral, so I have a 0 over here for my overall charge. Then what we need to do is we need to make sure we get our most positive down. So my most positive side is this one. So to get from 3 to 0, we're actually going to add 3 electrons over here. So this is my final one. Over here, let's work with dichromate. Notice here I have 2 chromium, and here I have 1 chromium. So I'm actually going to add a 2 here to balance that. But you're going to see that I have oxygen on the left, but no oxygen on the right. So we counterbalance that by adding water. I need 7 oxygen, so I'm going to add 7 waters. Notice that affects my hydrogen. So I have 14 hydrogen. I'm going to add that over here. Next, now that I have my atoms balanced, we have to make sure my charges balance. So here I have 14 plus 1 charges, so plus 14. I have a negative charge, one of them, so that gives me a total of a positive 12. Over here, if I'm looking at my charges, I have 2 positive 3s, so that gives me a positive 6, and then that's neutral. So I want to make sure that these equal here. So again, you're going to put the electrons on the most positive side. So how do you get from 12 to 6? You're going to add 6 electrons to bring that number down. So here, this would be your balanced half reaction. And last but not least, cyanide to CNO negative 1. Here I have 1 carbon, 1 carbon, 1 nitrogen, 1 nitrogen. They balance, but oxygen doesn't. I only have 1 oxygen, so we want to just add 1 H2O to the other side to balance that out. But here I have 2 hydrogen, so you're going to add 2 hydrogen to the right. Now that my atoms balance, I need to make sure my charges balance. Here I only have 1 negative 1 charge, so I have a negative 1 charge on the left. Here I have a negative 1 charge and then 2 positive charges, which gives me a positive 1. So I want to make sure these equal. Again, we're going to add electrons to the most positive side. So in order to do that, here, in order to get from 1 to negative 1, you actually have to add 2 electrons, because positive 1 minus 2 gives me negative 1. So this would be your balanced half reaction for this one. This can get a little complicated, so if you do have any questions, please make sure you ask. And otherwise I hope you guys have a great day.